Third method is angle side angle, ASA. Okay, just like before when we had side angle side, we had what was called the included angle. The angle formed by two segments. Well, now we have the included side, where the endpoints of our segment that makes up that side come from two different angles, right? Because the vertices of those angles act as the endpoints of our segment. That's what it means to be an included side. For example, VS is the included side of angle V and angle S. Or TS is the included side of T and S. Included side is a little bit easier. Okay? So to use angle side angle, what do? Well, we show two angles congruent as well as their included side congruent. Okay? Here we go. We're going to go through this one. Scroll down, give ourselves a little bit more writing room. Here we go. Circle the givens. VS bisects. Whoa, that's not what we wanted to do at all. VS bisects RST. There's that word and again. And it bisects angle RVT. What are we trying to prove? We're trying to prove triangle RVS congruent to triangle TVS. RVS congruent to TVS. Those two triangles here at the top and the bottom. We can already kind of see that there's a side that overlaps that may become useful to us. However, in the meantime, the givens. VS bisects RST and it bisects RBT. What does it mean that VS, that side, that middle chunk, bisects RST? RST is this big angle here. RST, it's the whole thing. When we bisect it, what we're saying is now it's been cut into these two little congruent halves. Angle RSV is congruent to angle TSV. Okay? That's what bisects means. Bisects means cut into two congruent halves. Bisects means to cut into two congruent halves. We have used the first half of the given. VS bisects RST. Well, VS also bisects the other angle, RVT. It bisects and cuts this angle exactly in half. So RVS, order matters, a little different than RSV. RVS is congruent to TVS. RVs are congruent to TVs. Why? Same thing, we're bisecting. We are using the fact that the definition of bisect means that the two halves will be congruent. That's what we are using here. We've used this. Look what we have here. We have an angle. We have another angle. Great. We've shown two angles congruent. Now we have to show the side, their included side congruent. We can kind of see the included side in the picture. If we look at the two angles, we'll just take the top triangle as an example. Here's one of the angles. Here's the other two angles. Or the other angle. Two marks to show it's different. The side that connects them, well, that has to be SV right there. It just has to be, because look at where those congruent marks are. Look at the angles that we're talking about. The side included there, that's the only one it could be. ST flies up to the top and VT flies up to the top. The only way to get from that one angle to the other angle is on that included side SV. Well, how are we going to get that into the picture? Fortunately, SV is in both triangles. It's the included side in both triangles. Since it's in both, that's like the idea of a freebie. We can say that SV is congruent to SV. Why? Well, we're using the same thing twice. This is an example of when we use the reflexive property. Now we've hit the side that we want. We have angle, angle, and side. Mark mark those little signs up here. Perfect. Okay, so now that we've shown angle, angle, and side, I'm going to move this one here so we have a little more room to write with. We have angle, side, angle. Two angles in the included side. We now have congruent triangles. RBS is congruent to triangle TBS. Why? By angle, side, angle. Let's review. We started here with bisecting that angle. Bisected gave us the two pairs, or the pair of congruent angles that we wanted. Bisected the other angle, we had another two pairs. Then after that, we needed the side that was included. We needed the side that went between those two angles. Fortunately, we have reflexive. So we have SV and SV because it was in both. We have the angle, the side between, and the other angle. We used ASA to prove these two triangles congruent. We are